Will we one day look back and divide astronomy into two eras, before Webb and after Webb? Honestly, it's hard not to think so. Something genuinely groundbreaking is unfolding, but we're still suspended between possibilities. Is this all a measurement glitch, a misunderstanding, or is the universe quietly hinting at new physics? Maybe a new form of dark matter, a fresh twist on dark energy. Something so monumental it could carry the weight of a Nobel Prize. The tension is real, and scientists feel it. Now, take a moment and really look at this image. What you're seeing isn't just a pretty picture. It's a beacon from an impossibly distant time shining through the early universe. And strangely enough, this glowing giant may finally help settle a mystery that's haunted astronomers for decades. According to everything we teach, the universe burst into existence 14 billion years ago. And soon after came a period of total darkness known as the Cosmic Dark Ages. Back then, space was choked with thick clouds of gas. Even with the strongest telescope imaginable, nothing should be visible behind that veil. But for years, hints of light, strange, stubborn light, have been seeping through those ancient clouds. Scientists couldn't ignore it, and now the debate has become impossible to brush aside. Recently, for the very first time, the James Webb Space Telescope captured two ancient galaxies hiding within that long-lost era. And the surprising part? They don't resemble the galaxies we know today. Their appearance has ignited a firestorm of questions. Are we misunderstanding the timeline of the universe, or misunderstanding them? That's the heart of the mystery. What exactly are these strange lights, and who or what is producing them? Webb's newest data may finally be the turning point. Its latest image reveals that the glowing light is actually powerful Lyman-Alpha emission, something we didn't expect to see coming from so early in cosmic history. And here's the twist. This image shows that galactic collisions in the early universe were far more common than anyone imagined before Webb. These rapid-fire mergers and the furious bursts of star formation they triggered are the engines responsible for producing those Lyman-Alpha signals. But that's shocking, because astronomers believed these emissions should have been smothered by thick hydrogen clouds during the Dark Ages. In theory, the light shouldn't have made it to us at all. But it did. And the reason is incredible. As newborn stars amassed in these primeval galaxies, two things unfolded at once. They generated Lyman-Alpha emissions, and they began carving out bubbles and tunnels of ionized hydrogen in the surrounding neutral gas. Those openings acted like cosmic escape routes, allowing the light to reach across time and whisper to us from the age before galaxies fully emerged. And then came the discovery that changed the conversation again. In another deep-field Webb image, scientists spotted two ancient galaxies existing even earlier than expected, before the universe should have allowed them to shine through the darkness at all. These objects are unlike anything seen before. Their extreme redshift suggests they're impossibly far back in time, so far that their very existence becomes a challenge to current cosmology. If these objects truly are galaxies, then the universe may have written its first chapter differently than we ever imagined. The James Webb Space Telescope may have just stumbled onto something astronomers have dreamed of finding for decades: the universe's very first generation of stars, forged almost immediately after the Big Bang. These ancient stars, known as Population 3 stars, appear to reside in a distant galaxy called LAP-1b, a system Webb had scrutinized before. And because its light has been traveling for an astonishing 13 billion years, JWST isn't seeing this galaxy as it is today. It's seeing it as it existed only 800 million years after the universe began. Essentially, we're looking directly into cosmic prehistory. One of the scientists behind the discovery admits that this moment may mark a historic first. If these stars in LAP-1b really are POP3, then this is the first time we've ever detected them, said team leader Eli Visbal of the University of Toledo in an interview with Space.com. He explained that identifying stars this ancient required not just JWST's incredible sensitivity, but also a cosmic stroke of luck, a 100-fold natural magnification provided by gravitational lensing. You see, LAP-1b is so unbelievably faint and far away that even Webb's powerful infrared eyes would never have spotted it alone. Instead, nature itself helped, in the form of a massive galaxy cluster positioned perfectly between us and LAP-1b. This cluster, MACS J0416.1-2403, located about 4.3 billion light-years from Earth, acts like a giant cosmic magnifying glass, bending and stretching the galaxy's light toward us. This effect, called gravitational lensing, was first predicted by Albert Einstein back in 1915, long before humanity had telescopes capable of proving it. And yet, here it is, bending space, magnifying starlight, revealing the universe's childhood. Thanks to this natural lens, JWST can see LAP-1b as it appeared during a crucial cosmic era known as the Epoch of Reionization, a time when radiation from the very first stars and galaxies began transforming the universe. Their ultraviolet light started breaking apart the neutral hydrogen and helium filling space, turning them into hot, charged plasma. When you look at this graph, you're not just seeing dots and lines. You're seeing the edge of the observable universe mapped through the incredible eyes of the Webb Telescope. Each point represents a distant galaxy pushed to the limits of cosmic time. Among them sits one famous object, GNZ11, first glimpsed by Hubble and sitting about 13.2 billion light-years away. But Webb has just revealed something far more dramatic hiding inside it, a supermassive black hole anchoring its core. And this isn't just any black hole, it's now the most distant one ever found, already fully formed a mere 400 million years after the Big Bang. Its size shouldn't be possible, not from collapsing early stars, not from ancient black hole mergers, not with the universe still in its infancy. Astronomers are realizing that our familiar explanations simply can't account for this monster's existence. Something fundamental is missing. And then the surprises keep coming.
There, two galaxies at a redshift near 16. If their distances are verified, it means these galaxies existed before the Dark Ages even ended. That's a huge problem for modern cosmology, because according to the Standard Model, galaxies shouldn't appear until after the universe's first light breaks through. Yet these early giants are right there, staring back at us. Massive, complex, and far too early. So what does that mean? Is the universe older than we thought? Did something unusual happen right after the Big Bang? Something that turbocharged the birth of galaxies? Spectroscopic confirmation is still pending. But if those measurements match the predictions, the foundations of cosmology won't just shake, they'll crack. In the middle of this uncertainty, a different idea is gaining traction: conformal cyclic cosmology. According to Nobel Prize-winning physicist Roger Penrose, our universe might be just one chapter in an endless chain of cosmic cycles called eons. In his vision, black holes in the previous universe slowly evaporated, exactly as Stephen Hawking predicted, and the final whisper of energy from those fading giants triggered the Big Bang of our own universe. Even more astonishing, Penrose suggests that some signatures, maybe even the seeds of early galaxy formation, might be leftovers from that past eon, nudging the growth of our universe before it should have begun. Scientists now suspect that the ancient dying black holes from a universe before ours might be the missing key, explaining why enormous black holes and massive galaxies appeared so impossibly early in cosmic history. And honestly, every new image from the Webb telescope keeps forcing us to rethink what we thought we knew. In just its first few years, JWST has shattered record after record: the farthest galaxy, the farthest protocluster, the farthest black hole, even the farthest red supergiant star, gravitational lens, or quasar. It's rewriting astronomy at a pace nobody expected. All of these discoveries quietly point towards something profound. Maybe the universe is far older than the Standard Model claims. Or maybe our universe is just one chapter in an endless chain of universes. Or, most mind-bending of all, maybe the cosmos never had a true beginning at all. If space is infinite, then perhaps time is too. In that view, the Big Bang wouldn't be a start, but simply a dramatic transition in a universe that has always existed, one moment in an ongoing cosmic story, rather than the first page. So now it's your turn. After everything you've just heard, what do you think? Are we living in an ancient universe, a cyclical one, or something even stranger? Drop your thoughts in the comments. I'd love to see where your imagination takes you.